All right, off we go again for the second half, starting with problem 60 here. Let's write the trig forms first for part A of our two standard form points here, root 3 plus I and 1 plus I. All right, so to turn them into trig form, this is A. We first need to find our r's. So r is going to be the distance formula. We've got square root of root 3 squared plus 1 squared. Remember, there's just one I here. So that's 3 plus 1, which is 9 plus 1. So 3 plus 1, rad 4, which is 2. And let's find our angle of 1 over rad 3, which is the same thing as saying root 3 over 3. And so if we plug that in, we're going to end up with 30 degrees. Look on your unit circle, plug it into your calculator. So here we've got 2 CIS 30 degrees. That's the first part of A. The second part is our second point. So r is going to be the square root of 1 squared plus 1 squared, which is root 2. Angle is going to be theta equals tangent inverse of 1 over 1, which is 45 degrees. So for our second complex number, we're going to turn it into rad 2 CIS of 45 degrees. So part A has two answers. All right, for part B, we want to perform the indicated operations. They're next to each other, so we're timesing. Let's multiply these two things together. So we're going to multiply the r's, 2 times rad 2, and get 2 rad 2. CIS, we're going to add the two angles together, 30 plus 45, and get 75. So our final answer, 2 rad 2 cosine I sine of 75 degrees. One thing to note, in the back of the book, sometimes, in fact a lot of the time, the answers will be in radians. So know that you just need to convert if you want to compare your answers with the back of the book if you're in degrees. All right, part C, perform the indicated operation using the standard forms. So we would just FOIL this, is what they're saying. So first, rad 3, outside plus rad 3I, inside plus I, and last would be plus I squared, which is -1. So I'm going to rearrange this just to collect the real terms together. Rad 3 minus 1 plus I rad 3 plus 1. Remember, there's 1 right there, pulling the i's out. So this is the exact same thing as this. This is our standard form. This is our trig form. All right, moving along to 70. 70, we're going to use de Moivre's theorem. That's French there. And do the 8th power of 3 minus 2i. So we need to turn into trig form first. So we're going to find our r for 70 equals square root of 3 squared plus -2 squared, which is 9 plus 4, which is root 13. And we need to find our angle, inverse tan of -2 over 3, which on your calculator will spit out a negative degree, I believe. Let me check. Yes, it does. We need to add 360 to that. If you add 360 to what's on your calculator, you're going to get 326.31 degrees for theta. All right, so we have rad 13, CIS 326.31 to the 8th power. Here's what we're going to do. We're going to take the rad 13 and raise that to the 8th. We're going to do CIS, the angle, 26.31, times 8. Multiply it out. All right, if you do that successfully, for 70, you're going to end up with, and I left the left this as root 13 to the 8th, but the angle does turn into 2610.47. And I left it there in the root 13 to the 8th because it says turn it back into the standard form, so we need to plug this into our calculator. We need to do cosine of this angle and times it by root 13 to the 8th. If you do that successfully, you're going to end up with negative 234 plus whatever the sine of this angle is times this again. And if you do that correctly, you'll end up with 28,560. And remember, this is the y term, the imaginary term, so that's going to be I. All right, let me erase this, and we'll do 80. All right, problem 80, we're going to turn this into our trig form as well. So r is going to be the square root of rad 5 squared plus negative 4 squared, which is 5 plus 16, which is going to be the square root of 21. And so our theta will be the inverse tan of negative 4 over rad 5. Plug that into your calculator, and you're going to end up with, for 80, 299.21 degrees. Remember, if you get a negative number on your calculator, add 360 to it. All right, so we have rad 21 CIS 299.21. Sorry, 299. And this whole thing is being raised to the third power. So we'll have rad 21 to the third CIS of 299.21 times 3. And if we do the cosine of this angle and we times it by rad 21 to the third, we're going to end up with negative 96.15 plus, if we do the sine and multiply it out, 4.00 I would be the standard form final answer. All right, 90. We're going to talk about finding the roots of these complex numbers. So what we want to do here is first turn it into the trig form. So we're looking at 90. All right, fourth roots of 625i. That's the fourth root of 0 plus 625i. Since there's no there's no real component, that's also going to be our r if we do the distance formula. So r is 625. If we go nowhere sideways but just up, that's going to give us 90 degrees. We're going to be at 90 degrees here. All right, so we've got 625 CIS 90 degrees. Here's how we're going to find our roots. We're going to take the fourth root of the r. That turns out to just be 5. And then we're going to take our angle and divide it by 4. And that's going to be 22.5 degrees. So our answer here is 5 CIS 22.5. However, when you do the fourth roots, we should have 4 answers. So this is just our first answer. Our second answer is still 5 CIS. And what we do is we're going to take 22.5 and we're going to add, this is what we always do, we take the whole circle, 360 degrees, and split it up into however many roots we're finding. So if it's fourth root, we'll divide by 4, that's 90. We're going to take this 225 and we're going to add 90. 225 plus 90 turns out to be 112.5. For the third root, we're still going to have 5 CIS. We're going to take 112.5 and we're going to add another 90. So we end up with 202.5. And for our fourth root, 5 CIS, we're going to add another 90. So we got 292.2. I'm sorry, 292.5. 5 for our 4 answers. Now in this problem, it does say represent them all graphically, and it does represent them in standard forms, so let's change those forms as well. Let me just create some space. In standard form, so this was part A. I'm going to jump straight to part C, because standard form says do the cosine of 22.5 times it by 5. If you do that, you end up with 4.62 for the first root. Do the sine of 22.5 times it by 5. You get 1.91i. So we'll do this all the way down. So the answers you'll end up with are negative 1.91 plus 4.62i. You'll start to see some repeat numbers. 3 is negative 4.62 minus 1.91i. And for 4, you get 1.91i. I'm sorry, 1.91 minus 4.62i. Now graphically, what does this look like? Well, we're going to start with our coordinate plane. And what we've got here is we've got a circle with a radius of 5. So this would be 5 comma 0. Up here would be 0 comma 5. Because that's the radius of 5. We're going to go out at 22.5 degrees. We're going to go out at 112.5 degrees. We're going to go out at 202.5 degrees. And lastly, we're going to end up at 292.5 degrees. So that's graphically what we're looking at. 4 answers. All right, last one, 100. Let's find all our solutions here. So if we move this around, we're going to have x cubed equals negative 1. So we want to find the cube root of negative 1. I don't see any i's in there yet, so we can say plus 0i. Alright, so we're finding the cube root of negative 1 plus 0i. So let's figure this out first. The r, square root of negative 1 squared plus 0 squared, is just 1. Our tangent, and this is an easy one to think about. We don't even need to do the tangent. If we went negative 1 and up 0, we're at 180 degrees, or pi. So let's find the cube root. We're going to do the cube root of 1. We're going to do 180 divided by 3. And so our first answer is going to be 1 CIS 60 degrees. How many answers should we have? We should have 3 of them. The r's are all going to be the same. And what should we add on to 60? We're going to take a full circle, 360 degrees, and split it up into 3 parts, which is 120 degrees. So we're going to add 120. 60 plus 120 is 180. 180 plus 120 is 300. Okay? So if we were going to represent this graphically, we would have a circle. It's actually a unit circle, radius of 1. And we're going to go up at 60 degrees. We're going to go out at 180 degrees. And we'll come down at 300 degrees. And that's it. That is 6-5. That's everything you need to know for Chapter 6. Questions? Ask me in class.